Okay, rocket, now it's taking off from the surface of the Earth, right? Total mass is 5,000 kilograms, 3,500 of which is fuel. So my initial mass is 5,000 kilograms. My final mass is 5,000 minus 3,500, right? That's 1,500, right? And that devilry was 5,000 minus 3,500, right? You subtract the fuel and then you get the 1,500 kilograms of final mass, right? Okay, and it's got an exhaust gas velocity of 3,000 meters per second. So let's see. So now let's figure out the thrust. That's the next step, right? So force times time is mass delta V. Our exhaust gas velocity is 3,000. It burns 25 kilograms of fuel in 1 second, right? And then we could find the force. So 25 times is 75,000. The thrust of the engine is okay. Let's see. For how long do the engines burn? Let's do that over here. So that's going to be, it's got 3,500 kilograms of fuel. So it's going to be 3,500 kilograms divided by 25 kilograms per second, right? That's the rate at which we're consuming it, right? The formula there is amount divided by rate. So 3,500 divided by 25. It's going to burn for 140 seconds. 140 times 25 kilograms a second will make that much mass, right? And now we got to figure out the initial and final accelerations of this, right? So the initial is, here's a 5,000 kilogram rocket, right? Okay, the force up is 75. And then the force down is going to be the force of gravity. So 5,000 times 9.81, which is 49,050 newtons, right? So that's the engines up, gravity down, and now we're set. We can go 75,000 minus 49,050 is 5,000 times A. Okay, so 70 minus that guy divided by 5,000. So don't forget to subtract the force of gravity. You get 5. Acceleration is a stately 5.19 meters per second squared. Okay, now let's find our final. Right, at the end there, we've got a rocket that has a mass of 1,500 kilograms. There's still an upward force of 75,000 newtons. And now the downward force is 1,500 times 9.81. $14,715 newtons. So now we're set. Now we can go 75,000 minus 14,715 equals 1,500 A. So we've decreased from this problem to this one. We've decreased the weight and the mass, right? It's got less inertia. It's also got less force of gravity, right? So 75,000 minus that number I just got, right? Divided by 1,500. I get the acceleration is 40.19 meters per second squared. There we go. So step 1 for these problems, find the initial and final mass. Step 2, find the thrust. Step 2.5, find any other annoying thing like the time it takes to burn, right? And then step 3 and 4 is find the initial and final accelerations using the thrust and the initial mass and the thrust and the final mass. Yeah? Yeah, yeah? Be clever.